Hey there, you're on Vectorly, and this is all about laws of motion. And today, the first question is: at a distance L from the edge of the table lies a block that is connected with a thread to another exact same block. The length of the thread is 12 and it is extended around the pulley sitting at the edge of the table. The other block is held above the table such that the string is under tension. Then the second block is released. What happens first? Does the first block reach the pulley or does the second one hit the table? Let's do. This is actually a highly conceptual question from SS Croto. First, people used to complicate it by taking things like it is moving tension T and there is a pulley out here. This is connected by a thread and you have another block which both have length L. Here the complication is this block isn't purely rotation. This undergoes purely rotational motion, whereas the left one undergoes purely translation on the surface of the table, whereas this undergoes rotation about the this end point of contact of the thread and the pulley. Now this case becomes too much complex if we calculate tension, normal reaction, and all these things. But there is a simple concept behind it. Let's take three cases. In which case 1, both of them, that is this block reaches the pulley at time t, at the same time this block touches the table. In that case, the initial center of mass is here. Let's mark COM is here at the pulley because the length is same and the mass is same. In that case, the block would be here, there would be pulley here, and the next block would be here. Here again, the center of mass remains at the same position. So net displacement of center of mass is 0. Center of mass displacement is 0. Let's go for case 2. In case 2, this block hits the pulley first and this remains in the air at the time of hitting. At the time of hitting, this hits the pulley. This is here. At this point, let's consider as point masses. The center of mass would be slightly shifted here because the mass is here over here and here the distance is approximately 0 and here there is a particular length. In case 3, here the center of mass moves right. In case 3, this block is somewhere here and this block comes below the table. In this case, the center of mass is about left. So COM moves left. Now, let's analyze the case. During a particular moment on the left block, the tension is acting in this direction, correct? Whereas in the right block, it makes an angle theta over here and a block here. The tension would be along this direction. So the net acceleration of COM in x direction would be t into 1 minus cos theta I cap. So at the initial moment, the acceleration of center of mass in x direction initial is 0 because both the tensions are in opposite directions. So they get cancelled by, actually it's m. not necessary. Let me write force acting on COM in x direction. So the net acceleration would be in the rightmost direction. So this block would move quick because the acceleration, okay, not quick. The center of mass has an acceleration in rightward direction. So the center of mass moves right. Correct? Due to this acceleration, the center of mass moves right. So this falls under the case 2. That is, the center of mass moves right. In that case, first the leftmost block hits the pulley. This is the shortcut for this question, and this is very conceptual and time saving. Question number 2. The wedge shown can slide without friction on a horizontal floor. Mass of the wedge is capital M and its angle of inclination is theta equal to 30 degrees. A block of mass small m slides down the wedge without friction when released on its inclined face. If path of the block relative to the ground makes an angle of phi equal to 60 degrees with the horizontal, find the ratio of mass of the block to that of the wedge. Let this be the wedge, and this makes an angle theta. This is of mass capital M, and let this be the small block of small mass small m. Now we are keeping this as our frame. Okay. Now the only acceleration this small block will have is along the wedge, which is A1. Suppose. Now this is not a surface, inclined surface. It is a wedge. So because of the normal reaction between these two, this wedge will undergo an acceleration in horizontal direction. Let that be A2. As this is accelerating, this must be a non-inertial frame of reference. This is a non-inertial frame of reference. Okay. For converting from non-inertial frame of reference to inertial frame of reference, we will add a pseudo force or pseudo acceleration to the block small m along this direction, which is A2. Because let me explain it clearly. From inertial to inertial to non-inertial frame of reference, while converting we will apply the pseudo acceleration in opposite direction. Okay, so if this is going in A2 in this direction, we will apply the pseudo acceleration of A2 in this direction, and the resultant is the A1 in this direction. So to get the acceleration in ground ka frame, we would apply it in the reverse direction A2. That is, we are going to subtract the thing pseudo acceleration. So we are getting A2, and the resultant is along this direction, which is a resultant. This is theta, and the whole thing is phi. Now the acceleration is only along this direction, resultant direction. So this is psi. So there is no acceleration in the direction perpendicular to the resultant. So A2 sine phi is nothing but which is equal to A2 sine phi is in this direction, and which is equal to this whole thing. What is this thing? Psi minus theta. So A1 psi minus theta, A2 into, sorry, A1 into sine of phi minus theta. This is the first equation I am getting. And the second equation is, if you consider the wedge and this block as a system, there is no horizontal force, correct? So the acceleration of center of mass ACOM in x direction is 0. What is the acceleration of center of mass in case of M? With respect to ground frame, if we take 0 is equal to small m into A2 plus capital M into A2. Small m into A2 plus capital M into A2 minus small m into A1 cos theta. Okay, because this makes an angle of theta. Theta is here, and this is whole angle is phi, and this is psi minus theta. Okay, the whole divided by m plus m. So you get m times of, okay, that is m plus m into A2 is nothing but small m A1 cos theta. So what I get is A2 divided by small m, 1 plus capital M by small m into A2 is nothing but A1 into cos theta. So 1 plus capital M by small m is equal to A1 cos theta by A2. Now I will substitute equation 1 there. Which would I which would I get? 1 plus capital M by small m is equal to A1 is nothing but A2 sin phi cos theta whole divided by A2 into sine of phi minus theta. So A2 gets cancelled, and 1 plus capital M by small m is equal to sine phi is 60 degrees, that is root 3 by 2. Cos 30 degrees also root 3 by 2. Whole divided by sine 30 degrees nothing but 1 by 2. So we get 3 by 2. So capital M by small m is 3 by 2 minus 1, which is 1 by 2, and small m by capital M is nothing but 2. That is the required answer. Small m by capital M. Okay. One end of a light inextensible cord is attached to a nail A on the ceiling. The cord passes through frictionless hole of a small bead P. Thereafter, it passes around two ideal pulleys, and finally, the other end is attached to the bead. Initially, the bead is held at rest with the cord segments AP and BP making an angle alpha and beta with horizontal, while keeping the segment CP vertical as shown in the figure. Find acceleration of the bead immediately after it is released. Acceleration due to gravity is G. Now, this string is a single one. Here it goes through the bead and comes out, goes through two other pulleys and tied at the other end. Now, as it is a single string which is inextensible, the tension here would be T, here also it's T, and here also it is T. Now, the acceleration would be AY in this direction, AX in this direction. Now, let's write the force equations. So force in x direction is nothing but t cos alpha plus t, sorry, it's t cos alpha plus t cos beta. Force in y direction is nothing but t plus t sin alpha plus t sin beta minus mg. Now this is m into a in horizontal direction, and this is m into a in vertical direction. Now the next equation is summation t dot a is 0. Why this is required? Because we have the variables of m, ax, ay, and t. So we have to take all the possible equations. Now summation t dot a is equal to 0, which implies t cos alpha, the t cos alpha dot ax, so in the same direction. Similarly, t cos beta into ax, there plus this t and ay in the same direction. So tay, similarly t sin alpha into ay plus T sine beta into ay is equal to 0. Upon cancelling all t's, what we get is cos alpha plus cos beta into ax is equal to minus of ay into 1 plus sine alpha plus sine beta. Okay, now let's keep this as p and this is q. So ax is nothing but minus q by p into ay. This is another equation. We are going to substitute this in the first equation, which is so p into p is equal to minus may into q by p. And what is the next equation? T into p minus mg is equal to may. Sorry, this is tq. So what I get is t p square by q is equal to minus may. If I substitute it here, tq minus mg is equal to minus tp square by q. So if I move it, mg is equal to t into q square plus p square whole divided by q. So t is nothing but mg into q by q square plus p square. Now all I want is ax. So ax is nothing but t by m into p. So mg into pq by q square plus p square. If I divide by m, I will not get this m. So g into pq by p square plus q square is ax. Now ay is t into q minus g divided by mass m. So t by m gq by p square plus q square q square by p square minus g, which is g into p square by p square plus q square. If you want, you can skip the calculations and check your calculation. Just do it by yourself. Now, a resultant is nothing but root over ax square plus ay square, which is nothing but under root. What is ax square? G square p square q square by q square plus p square the whole square plus g square p power 4 by p square plus q square the whole square. So a resultant is nothing but by taking g p by p square plus q square, what you get is under root q square plus p square, which is g p by under root p square plus q square. Okay, now find the acceleration of the bead immediately after its release. This is the final resultant acceleration a, which is g p by under root p square plus q square, whereas p is cos alpha plus cos beta and q is 1 plus sin alpha plus sin beta. Question number 4. A homogeneous rod AB of mass m and length L leans with its lower end against the wall and is kept in the inclined position by a string DC. The string is tied at point C to the wall and at point D to the rod so that AD equal to AB by 3. The angles formed are marked in the diagram. Find all possible values of coefficient of friction mu between the rod and the wall. Now, There is actually three cases in which friction acts upwards, frictional force acts downwards, and there is no friction at all. There are three cases. Okay. First of all, for an equilibrium, if a body is said to be in equilibrium, it is in translational equilibrium for which F net is 0, and rotational equilibrium for which tau net is, that is torque net, is also 0. If net torque is 0 about any point in the plane, about any point, it is 0. Okay. So it must be 0 along the line of, or the point of intersection of all the force lines, the lines of force, points of intersection of lines of force. Correct. So if tension is acting in this direction and mg is acting in, not here exactly, and mg is acting here, if they are meeting somewhere here before the line joining the normal reaction, let this be the direction of normal reaction, up above the line of normal reaction, uh, the friction should act upwards because the torque produced by tension and weight at this point is 0. But there is a torque produced by this normal reaction. In order to compensate it and make to 0, the resultant reaction should pass through this line. So the friction should be upwards. At the same time, if this point is here, the friction would be 0. At the same time, if this point is here, the friction would be downwards. Okay, this is the concept. Now, let me take the first case, that is friction is upwards. If friction is upwards, let me calculate the value of mu. You calculate the remaining. Okay, case 1, friction acts upwards. If friction acts upwards, let's take this as the rod with weight acting downwards and tension is acting somewhere over here. And this angle is alpha and this is beta. Okay, and this angle is beta. Now the normal reaction acts over here, and friction, which is mu n, acts over here. Now the component of tension in vertical direction is T cos alpha, and in horizontal direction is T sin alpha. So now T sin alpha is equal to normal reaction, and mg is equal to T cos alpha plus mu n. So mu times of T sin alpha. Okay. Now these equations we apply via translational equilibrium. Now for rotational equilibrium, let's take this point as the axis of rotation. Now the torque produced is whole angle is alpha plus beta. So T into L by 3 into sine of alpha plus beta is equal to, the counter torque is produced by mg. So mg into L by 2 into cis b. This angle is 90 degree minus b. So L by 2 into sine beta. Okay. Now let's cancel out L. So we get T is nothing but mg 3, 3 by 2 mg sine beta whole divided by sine of alpha plus beta. Now from this mg is equal to, I'm taking this second equation from 2, right, from 2, mg is equal to t into cos alpha plus mu sin alpha. So here we take mg by ts 2 by 3 sine of alpha plus beta by sine beta, 2 by 3 sine of alpha plus beta by sine beta is equal to cos alpha plus mu sin alpha. Write 2 by 3 sin alpha cos beta plus cos alpha sin beta is equal to cos alpha sin beta plus mu sin alpha sin beta. On subtracting it, what I get is 2 by 3 sin alpha cos beta minus 1 by 3 cos alpha sin beta, which is mu sin alpha sin beta. And now let's divide by sin alpha and sin beta. So what you get is 2 by 3 into 1 by tan beta minus 1 by 3 into 1 by tan alpha, which is equal to mu. So I'm taking 1 by 3 into 2 by tan beta minus 1 by tan alpha, which is equal to mu. And now mu is always greater than 0. So 2 by tan beta minus 1 by tan alpha should be greater than 0, which implies that 2 tan alpha is greater than tan beta. This is the case for condition for case 1. Similarly, we have to find the condition for case 1, 2, and 3, and then we have to take the intersection of these three. We have to take the intersections. Take the intersection of condition 1, 2, 3. And then finally we will get the condition for alpha and beta. Thank you for watching this video. Type your doubts in the comment box below. Stay tuned with Vectorly.